nice well, it's a animation of the satellite animation of an example of how Torvas evolved. Initially as a well, it's not initially as a baroclinic cyclone and a warm seclusion cyclone, but at the end it showed up that the convection started to surround the cyclone, and it underwent a tropical transition, no, and you can see also the eye emerging from the convection. So this is the type of eye that we were talking yesterday. That this must be the ones that must be identified in order to say that in this case they are suffering a tropical transition. So what we use is the high floor model, which was shown to be the best, the first reliable model, global climate model, and coupled to simulate well hurricanes of very high intensity hurricanes. And so that's why we thought of using that for Medicanes, and also it did a good job. So we we use it. So I'm going to go to the main points. The idea, well, we did a study about the Medicane. Well, this is all based on the cyclone space and for the D1 core and non-frontal cyclones. So what we find is an increase in the duration of cyclones that reach those stages, no? In this in the different temporal evolution. And well, I'm going to skip that because it is not important. So we found also increase in the intensity, as already was published in previous papers from other approaches and regional climate modeling. So the model was also seeing the same, no? But the new metrics or the new analysis that we did there was also to study precipitation, and also we find an increase in the precipitation structure of these cycles, right? But also we came up with some index like the tropicality index, which is a measure of all the time steps that the cyclone is above or at least a deep 1/4. And also we find that these cyclones tend to have an increase in this kind of in this index, right? So they tend to be more in the stage of as a deep 1/4. Also, we study the power dissipation index. The main idea is that we find an increase of the destructiveness of the activity of these cyclones in the late runs, and mainly in autumn seasons. No, so this is another, because Medicanes were thought to mainly develop in winter, but in this case, these results were saying that no, they will that the activity will increase in autumn months, right? So, well, we also analyze a future case in the model, and and the model is able to develop a hurricane-like structure, and in this case, it was like a category 2 hurricane. So the idea, no, the conclusion was that that model, that the good thing was it was coupled. So that's that is able to simulate the interaction with the ocean, and it was the first model to use like in this kind of model to study Medicane. So we find an increase in the frequency, but they potentially become more hazardous due to increasing wind, duration, rainfall, and even in an intermediate scenario. No? So the changes mainly occur in autumn and are associated with a more robust hurricane-like structure. So at that time, I put something like this, no? So maybe at the end of the century, based on these results, we will see this kind of cyclones in the Mediterranean Sea. But this was before Llanos, and it was when Llanos came up. So you can see the similarities, and Llanos was an event in September. So it's the kind of events that the model was saying that they could be more prevalent in the activity. No? So it's an idea that the model was already seeing, and also if the model only developed this kind of of cyclones at the end of the century and not in this climate context. So this is another question to ask. No? But the problem that is that this study was based on the cyclone phase space. But the problem is that the cyclone phase space is not the perfect tool to study this kind of cyclones because during the courses of the years, initially I thought, well, most of the people thought that the one seclusion only reached the lower, the 1/4 only reached the lower troposphere. But there have been some cases. I don't know if it's because of the model that they are getting more resolution, and that's why we are able to see that some one seclusions can reach the upper troposphere in the one anomaly can reach the upper troposphere, and they also can become non-frontal. So based on the CPS, this is a problem. So that's why we started to think about creating or thinking about creating a physically descriptive cyclone phase space. Well, initially for Medicane cyclones, the first initial focus, but the idea is to extend it to other basins. I'm not going to go into details in this work, but this is a work we are been doing quite slowly because it is not the main focus of my work. But we have been getting some results. So, for example, if we move to the North Atlantic, we have Hurricane Alex, which is a tropical transition with a warm seclusion, and you can see at this here, you can see that Alex, before going into a tropical transition, it went into a deep one core as a warm seclusion, and also reaching the non-frontal structure with this between A and B. B is as a tropical cyclone, so Alex is a cyclone that it went through the different stages. And also, we have another example that Sorbas had a similar behavior. We studied that, the one that Manos showed yesterday. And the same happens, that Sorbas has a deep one core phase, but it's a warm seclusion, so it's a pyroclinic cyclone before getting the stage of the tropical transition. So that's why we started to think that, well, maybe we have to separate warm seclusions from really tropical or really tropical transitions or more tropical or D1 core from tropical activity. No? So this is the study that we also did. Jesus was developing, leading the work and calculating all the results. So the idea was to refine the classification, or not the classification, but all the cases that are potentially tropical light or Medicanes, to do a new refinement and to say, well, this could be a warm seclusion, and you are saying that it's a Medicane, no? Or a tropical light cycle. So, but you can have a look at the poster also. Well, so I'm going to skip. So the main idea of this work is to use based on this paper, where they do a objective classification of tropical cyclones based on different parameters. So our aim is to take these parameters to build a more complementary cyclone phase space that can explain why the cyclone is going to this part of the cyclone phase space and what are the processes that are making this happening, right? So I'm not going to enter into detail, but the idea is that, so initially we have this kind of diagram where the x-axis is an idea of the upper level forcing, no? And the other parameter is about the lower level forcing and molecularity. I'm not going to enter into detail because I want to show better another things. But the idea is that, for example, here we are able, it seems that we are able to explain. So cyclones that goes from one region to the cyclone phase space. This is a little bit noisy. I'm not going explain in detail, but you can ask me later if you want. The idea is that if we choose different cyclones that go a different direction in the cyclone phase space, this new physically cyclone phase space is able to distinguish between these transitions. No? So we are able to explain, well, we could be able to explain why this cyclone is making these transitions in the cyclone phase space. So yeah, the general conclusions are, well, this is already in the early stage, but we have already got some nice results that we hope to publish in the future. But the idea is that based on this PCA analysis, we can infer some of the physical transformation of the cycle. But yeah, the idea is that we have to move this to ERA 5, first to use it in an operational context, see that if the real-time cyclones, the results are also fit with the real-time cyclones, and different kind of things. So the other thing I wanted to include here is the task with the National Hurricane Center. If we are able to, based on the subjective classification, if we are able to get some parameters that can summarize this and merge this information. So it's quite ambitious, but we will try. So another thing that thanks to the MX cyclone construction, I went to Zurich again to study because we realized, well, when I was there, I realized that with the Lagrangian trajectories, you can also have an idea about the structure and the evolution of the cycle. So the idea is, well, maybe if we include also this is more complex, this is more a little bit more of work, but the idea is that first we use the Lagrangian trajectories and then to derive something more to have the same idea. So, well, this was part of a project that I got for the a Marie Curie project, but I didn't do it because I got up the position in National Weather Service, so I had to choose. It was a permanent position, but it was supposed to be a task from this project. No? So the idea is to first identify what is or how could we identify a tropical transition and then use it for climate projection. So this is an example of the figure that I will show you. We have the Lagrangian trajectories over a cyclone, no, with the pressure, and here we have the CPS, the cyclone phase parameters, and then the status by the National Hurricane Center. No? So we have this is Hurricane Leslie. This is a good prototype to show the complication of these kind of processes, because here we have, based on the National Hurricane Center, is first extratropical, then subtropical storm, then extratropical again, and this when a warm seclusion is happening. That's why the cyclone phase space is aware of that, and it says, well, this is a non-frontal deep one core. So if you base analysis on the cyclone phase space, you are identifying a tropical cycle, but not. No? So the idea then it went through again through a tropical phase and then a tropical storm. So it was this. But at the end, the shaded region, no, is the non-frontal D1 core. At the end, the cyclone based on the cyclone phase space are in the same situation. So the idea is this. Let me show. Yeah. So this is the animation of the evolution of the cyclone based on these kind of panels. So we can see, well, there is a. So this is the next region is The information is coming back, so let's say this video. So, well, as we see, sorry, yeah. Yeah, okay. So, well, the best the best point is to go into the subtropical phase. So you can see also an increase of the trajectories, no? that go because we are making a filter and we only plot those trajectories that ascend 600 hectopascal in 2 days. So you can see an increase of the trajectories, but the main ascent is to the right of the cyclone. So that's why there is a mix of pyroclinic processes and tropical processes happening, but we can already see there that this is a more baroque. This is no, it has a pyroclinic contribution because the main ascent is to the right of the cyclone due to the trough and so on. But if we go into the warm seclusion phase, there is an increase of the trajectories and see how also the low level center goes into where the region of maximum ascent, no, where you have all the trajectories ascending. So in the cyclone, in the warm seclusion, there is also an increase of trajectories, but the shape of these trajectories and the behavior is quite different to this stage that we will see later. So the idea is, well, now the problem it comes because now you have a strong vortex, no, in the sea level pressure. See a strong vortex, or if you only see the sea level pressure, you could infer, well, this could be a tropical cyclone, no? And also in the cyclone phase, the cyclone is approaching to the non-frontal deep one core, no? But thanks to the Lagrangian trajectory, we can infer that the cyclone or the cyclone, the circulation mainly horizontal and not vertical, no? So that's why all of the trajectories are removed, no? So this will be a good idea, a good method to say, well, this is a warm seclusion, but we are seeing a deep one core frontal, but this is a warm seclusion because the circulation is mainly horizontal than vertical. But now we are heading into the tropical transition phase, and you will see now how the cyclone and the trajectories get shape of a tropical cyclone, also a hurricane. So there is an increase of the trajectories. You see how the shape is different, and also you can see a tropical shape in the trajectory. So now we are in this phase, in the non-frontal D1 core, but we can realize that this is a tropical cyclone forming. So the idea based on this, well, then we also can infer how the cyclone interacts with the mid-latitude circulation here, because also the structure gets like more tilt, like here. So this is and also when the National Hurricane Center decays the intensity, we can see also that the structure is loses the robustness, so that's why it's losing the intensity. So the idea is that based on this, to summarize a parameter that can give you an idea of these whole processes, and well, I still have to think more about that. But in black line, you can see the tropical transition potential, and you can see that there is first an increase of this index in this region, but when there is a warm seclusion, the index doesn't tell you, or tells you that there is not any tropical transition potential there. But it's when you have the tropical transition when the index increase. And this is not following the same evolution as the cyclone phase space, as you can see, because cyclone phase space there is increasing the BTU value. So it's a non-frontal one core, but this index can tell you that this is not a tropical transition. So we are still working on that, but let's see what happens. So, well, that's all. Well, this is just to prompt some discussions about the different points that. So the main idea is that the cyclone faces space. Well, forgot this. Yeah. So the key message is that the terminology and definition is not important, but it's important that it's more important the impact and the informing them about them. But what is important is that we are talking about the same phenomenon. Because why? Because for climate projection, if we want to do climate projection, we want to be sure that we are talking about the same phenomenon. For forecast predictability and conceptual model, also the same, because one seclusion do not behave for tropical cycles or tropical life cycles, do not behave in the same way in the numerical model, as tropical transitions or tropical cycles. And also important too, because we want to, it's also, it would be nice to inform the media or society about changes that could be happening in the structures of the cyclones. No? So we are able to explain why this is happening or not, and why these changes are happening. No? So that's the idea. Yeah, so I see everything. So just nice, just a little bit of off topic, but it's related to the Mediterranean. So it seems that also the convective events, not only Medicane, but the convective events are getting more intensity in the Mediterranean Sea. So this is a nice example of a derecho in the Mediterranean Sea that we were able to attribute to climate change. So if you want to take a look, it was the case. It had a lot of impact, but so okay, that's all.
Now it's open for questions. Also, the study that my student Luca did, where we saw this. We look at 20 derechos in France in the last 20 years, and we see a clear effect also on anthropogenic climate change in increasing the wet conditions and warm conditions near the ground, which then can trigger convection and also perhaps these tropical phases of the cyclone. So yeah, the floor is open for questions. Yes.
A question about the last method you show. You think it can be applied also to the Mediterranean, considering that the scale is completely different?
Yeah, so that's the problem, that we first apply this to a tropical transition in North Atlantic because they are bigger, and ERA 5 behave well with this kind of cyclone. The problem is that with the Mediterranean cyclones, ERA 5 doesn't represent them well on the structure, because I try this for sorbas and information is more mixed. I have to take a deeper look at the it doesn't, it's not so well and clear as this case of, so let's see, but ERA 6 is supposed to come and it will halve the resolution, so let's see. Or at least in numerical models.
When it comes, then we have to download it, so that it can be some delay. Okay, yeah, more questions? Yeah. Oh, I'm stuck.
That probably was loud. You mentioned AI, and it made me think about something that we did some years ago with my colleague Prabhat, who has since moved on to corporate. But we trained a machine learning algorithm that I kind of call the Facebook app to find tropical cyclones in long data sets. And finding them, like emulating heuristic detection algorithms was actually very straightforward. What we did after that is we had a hackathon with postdocs and students to try to draw contours around the storms to get, to do the Facebook thing, where you say, okay, this is a person. So this is a tropical cyclone. This is an extratropical cyclone. This is an atmospheric river. And so I have no doubt that some of these structural features that you showed could this Facebook app kind of image recognition could easily be trained, given a training data set. Now, well, we found that you need about 1,000 images to train on, but you don't need 1,000 events because they could be different images, at different times of similar events. So I don't know if that's what you wanted to do with AI, but it's certainly an opportunity, I think.
Yeah, that's the idea, because, for example, for this case, this is based on the cyclophase space. This physical descriptive cyclophase space is based on a PCA analysis. So this is very simple. And maybe the machine learning algorithm are able to also put in this kind of images like the Lagrangian trajectories, or I don't know. But it's a topic to think about that. But we can talk about that.
And once it's trained, it's very fast.
Yeah. Yeah, so that's the main point. Yeah.
Okay, so in the interest of time, we have to move to Marcello's talk. And Marcello, thanks again for your presentation. We will have time to discuss this more. Marcello, we were also wondering if you then would like to share the discussion. Yeah. Like when he's asked like this, can you really say no? Yeah. Now the question is, can you really say no after we? Yeah, I mean that's just yeah. So while they switch, if there are more questions, we can take them. Okay. Quindi ti connetti allo Zoom.
It's very busy today, yeah. You put me option di tutorial. Marcello, il giorno di Marcello. Hai condiviso lo schermo su Zoom?
Okay, so the next speaker is Marcello Miglietta from the CNR ISAC and Università degli Studi di Bari. So Marcello will talk about Medicanes.
Okay, can you hear me? Okay, so thanks first of all for the invitation to this very important and fruitful meeting. I hope that we can go out with some definition after this days. And what I want you to the idea of this talk is to.
Ok, so Marcello bisogna accendere il microfono. Dietro questo non questo il microfono. Off, on. Te lo lascio mettere per fare ricadere.
Okay. So the idea is this talk, the outline is the one you see here. First of all, I will provide you some information about some interesting, I think, case studies that emerged in the past. Then I will move to describe some common characteristics of Medicanes, also in comparison with some tropical-like characteristics. And then I will move in the last part to some more recent results about what should include or what was discussed in the literature about the meaning, how the term Medicane should be used. First of all, I would like to show one of these first image of one of these tropical-like cyclone in the Mediterranean. Here we are in the Ionian Sea. And clearly, this is one of the first image that shows that cyclone with the characteristic typical of tropical cyclone can be observed in the Mediterranean. Then there were several studies analyzing and identifying the similarity not only visual but also physical with some characteristic of tropical cyclone. My personal interest in this started with this case. We were in the office with Rich Rotunno here in the Hill of the Boot in Italy. No? And then we suddenly see this intensification of the wind. So Rich told, but this is an hurricane. And really, when we look at the radar reflectivity map, we saw this structure. No? It was a simple radar, but effective to identify this band of rainfall around the center. And it was interesting to see that really both the National Service analysis, but did not identify anything particular, just at the time of the landfall. It showed just a minimum pressure of 1002 hectopascal, nothing particular occurring. And really also the ECMWF analysis strongly underestimated this case, probably because of the small scale and the fact that it arrived from the Ionian Sea. But when we interpolated the station available at the time, we found a completely different situation. In fact, we found a minimum pressure of about 986 hectopascal, moving rapidly from one side of the other of the peninsula. So consider that it is about 40 kilometers wide, and it took about 1 hour to cross the peninsula. There is a synoptic station just in the middle, just over here. And so the data that were available are really, I think, impressive to explain what was going on. You see a progressive intensification of the wind speed in the first phase when the cyclone approached the station, then a reduction just in correspondence with the minimum, and then the new intensification up to 78 knots. And even more impressive is the pressure evolution. No? You see that there was a change of about 13 hectopascal in about 1 hour and a half. So this was the beginning of a number of studies in which we identified from numerical simulation that the cyclone has a long story. In fact, it started as in Northern Africa for Lee cyclogenesis. Then there was a phase where, in particular, the low level was moistened by interaction with the sea. So you progressively see a change in the thermal profile that becomes more favorable to instability. Then the phase in the Ionian Sea, where also due to the interaction over upper level disturbance, convection was triggered, and there was a very strong, very intense precipitation. And finally, the last phase, where the cyclone self-sustained as a combination of the surface fluxes and the latent heat release. Another interesting case study I wanted to show is this that occurred in 2014 in Sicily. And this is a case I decided to put at the last time, at the last minute, this case, because if one wants to investigate the predictability, this is probably one of the most uncertain cases, in the sense that there are different explanations for why the operational model failed to reproduce this displacement northward. If you look at the operational map at that period, you will see that they missed this northward displacement. So probably this case, even if it's quite old, but still requires some further investigation. And finally, I will show this map about Llanos, which is clearly a sort of reference, for studies of Medicane, because it's probably the most intense up to now. This map, a combination of high resolution visibility and cloud top temperature, shows that initially you have a lot of convection developed in the southern Mediterranean, and then only at a later time you see a clear cyclonic circulation getting around this structure. Then you see that the cyclone progressively move eastward, reinforced by the interaction by the jet stream at that time, and then the impact, very strong impact on Greece, where in some stations there was recorded almost the precipitation of 1 year in just 48 hours. Medicane characteristics. So I would like in this part to provide some information about some particular feature now that are common or differentiate Medicanes with different categories somehow. The starting point is what was shown by Kerry Manuel the other day. So the first the reference paper about the Iranian hurricane is this paper from 2005, where this Ionian cycle was discussed. And in particular, the axisymmetric cloud resolving model was able to predict strong potential intensity when you put a cold upper level low and at the beginning of the simulation. And the model is only based on the feedback between surface enthalpy fluxes and wind. So if you look at the wind structure, in this case, a normal question to ask is, can you see something similar to what you would expect in a tropical cyclone? So you can see a typical donut shape feature. In some cases, this is true. For example, this is the case of 2009. This is in this map are shown azimuthal average. The center of the cyclone is here. And this is a radial direction. And this is and the y-axis. It's the height. So you can see that in the top panel, it's shown the presence of a maximum wind at about 20-30 kilometers from the center. In the low level, the presence of wall core, some upward motion at the side of at the eye wall, and descending motion in the center with the clouds forming mainly at 20-30 kilometers. This structure is similar to what Stavros showed the other day for Zorbas, but when you look, for example, at the poster by Jesus outside, you see that this trend, this reduction in the structure of the wind, progressively get closer to the center of the cyclone, is not common to all cases. So this is a way that differentiates somehow the behavior in all so-called Medicanes. The other point is about the mechanism of development. Again, from a Kerry Manuel paper, the basing, the forcing is the development under a deep of flow at upper levels that generates the thermodynamic disequilibrium, and is associated with the trough. So you have an upper level at the top, you have the upper level low. There is generated a cyclone in the low level. And so for sure, there is a baroclinic component at the beginning of the cyclone lifetime. This case is a case in January. So for sure, the sea surface temperature is not as high as in a tropical cyclone. So apparently, sea surface temperature is not a key role for the genesis. But at the same time, when you make some sensitivity experiment to the surface temperature, you see that clearly the presence of a warmer sea surface temperature tends to affect the intensity of the cyclone. Here are shown, the color refers to equivalent potential temperature, the contour to sea level pressure, and you see that for the case with a higher, the warmer sea surface temperature, you have a stronger structure, more intense wind, while cases with lower sea surface temperature tend to reduce the intensity of the cyclone. And these results are common to other cyclones. Here are shown for Llanos, but really other studies show similar results. On the other side, as I said in the previous slide, there is a baroclinic component for sure at the beginning of this cyclone, but at the same time, in the Manos figure that was discussed already yesterday, you see that even in the mature stage, now the red points, which represents Medicanes, show a contribution from both sources. So you have a diabatic contribution to the 850 hectopascal relative vorticity that for a few cases is really the main source, but in general, you have a contribution of both sources. So for sure, Earth's interaction seems not to be exclusive in the development of this cyclone in the mature stage. Moving to some other features that characterize Medicanes, another result that seems common to all the cases that have been studied up to now is the behavior, the discussion in terms of lightning activity. Again, there are some studies passed in several stages that analyzed this aspect. And in general, what emerges is always something like that, that in the mature stage, so when the cyclone shows tropical characteristic, there is a strong reduction in the number of lightning, in the number of strokes. The lightning activity seems to be reduced in all cases reported so far. About a difference instead is present in terms of convection. For example, this is a case of deep convection in Llanos. Again, you see that you can have a very high cloud top in some part of the cyclone, reaching up to 10 kilometers, even in the mature stage. We are here in the phase where the cyclone is approaching Greece and shows a deep warm core structure. But again, when we look at other cases, we saw a different behavior. This is a paper of 10 years ago. We analyzed several cyclones, mainly from using algorithm based on satellite. So the red refers to deep convection. And for example, in this case, which is Rolf, I think, in affecting the Western Mediterranean, you see deep convection mainly in the development stage, but then in the mature stage, convection seems to be sharper than before. And this was again found in several cases, but not in all. As I said, Llanos has a different behavior showing deep convection even in the mature stage. The last point I would like to discuss is the important role of upper level dynamics. This is again the case of 2006. The color here refers to potential vorticity. The position of the cyclone is represented by the star that you see progressively move northward from left to right with time. And you see that the strongest intensification, at a certain point, the PV streamer interacts with the cyclone. And this is the phase when the cyclone intensifies the most. So for sure, there is an important role of the upper level feature to development of the cyclone. And the key role of this feature is also shown. Now, this is again, this is a movie that shows our cyclone. In brown, you see the potential vorticity generated by the abatic sources. And you see that intensification occurs mainly when there is this upper level feature wrapping around this cyclone. Okay. But the importance of the upper level features is also addressed in terms of predictability issues. You already see this paper mentioned several times, but I think it's very crucial to understand how important are upper level dynamics for the development and for the predictability of this case. Again, there was a set, an ensemble of different simulations for Zorbas, and only the cases, the simulation where the PV streamer was located at the right position, so in the central cluster, were able to reproduce an evolution consistent with what was observed at the end. the one showing a PV streamer too far east or west produce a completely different evolution. And it's important that this is related to shortwave perturbation on the North Atlantic waveguide a few days before. So a small contribution, initial contribution, then evolve in a completely different way. The last part is about more recent studies. And this studies raised, put, I think, in a different perspective compared to what at least I understood at the time, what is really what is considered as a Medicane. This first case shows a case developing in the Western Mediterranean, and the conclusion was that the deep warm core, the evolution you see in the top panel of 500 hectopascal shows that a sort of evolution that can be interpreted in terms of a warm seclusion. So apparently diabatic processes are in place, but do not seem to be fundamental to explain this kind of evolution. And a similar conclusion was obtained by a paper by Manus and Novitz-Fita about Zio. The conclusion was very similar. So the studies were parallel, and somehow they were published just a few months apart from each other. And the conclusion was similar. Warm air seclusion seems to explain the presence of a deep warm core in the center of the cyclone. So following these two papers, with Richard Uno, we tried to analyze two cases, so Cornelia and Zio, and we reproduced the evolution with the Wolf model and looked at the vertical cross-section passing through the center of the cyclone in the major stage. And what we found was that the two cyclones behaved in a very different way, in the sense that in the middle, at the center of the cyclone, you have in both cases a warm core, but the structure associated with this evolution seems to be quite different. In one case, you have convergence in the low level. This is the cyclone relative wind, so convergent middle, uplift along absolute momentum line, and a nearly neutral environment on the left. While that in the right case, the behavior is completely different. So the evolution, the kind of development of these two cases apparently is different. And it was interesting also to have a look at the different distribution of the two cyclones in the low and in the upper level. For example, for the first cyclone, for Cornelia, there was the comment of yesterday about the track, the concentration of cyclones along these valleys in Iberian Peninsula and in France. Really, you see that in northern, if you look at the sea surface flux, there is a strong intensity just at the area where these local winds, Mistral, Tramontana, and Certo, arrives in the Mediterranean. So this feature produced already before the development of the cyclone and produce a lot of exchange between the ocean and the atmosphere. So it seems to produce somehow an environment favorable for the later development. While for the other case, which is shown on the bottom side, you see that the maximum fluxes seems to be related to the cyclonic circulation itself. So it seems to be quite a different low-level structure. Even more interesting, I think, is the upper level evolution. If you look, this is the PV at 9 kilometers. You will see now some lines that are the contours of sea level pressure. You see that, for example, for Cornelia, you have a development that at the beginning occurs within the large scale feature, but then in the later stage, when the cyclone reaches the Tyrrhenian Sea, PV tower is generated by the fact that you have a lot of convection. So it seems that you have a diabatic generation of potential for this stage. If you look at the other case, it is a completely different evolution. The cyclone forms and basically develops within the upper level PV feature that was responsible for its generation. So at the end, considering this different behavior, our conclusion and similar conclusion were reached also by Stavros from a different perspective, is that so the term Medicane really seems to be used to represent to cover a wide range of the continuum existing between extratropical and tropical cyclone and for cyclone in the Mediterranean. And so the idea was to represent, to distinguish these two categories. On the one side, some shallow, but can also have a deep warm core structure, mostly driven by baroclinicity. So there is a contribution by both baroclinic and the diabatic processes. In general, you cannot see deep convection in this case in the major stage, but mainly in the development stage. And the other, like Cornelia, mainly driven by strong diabatic processes. So this kind of cyclone are closer to, can show real tropical cyclone characteristics for a limited period of time. And this is a slide from Juan, but it represents more or less the same idea. So, and is in agreement with what Kerry discussed the other day. So try to make a sort of separation, as in the northeastern Atlantic, between subtropical cyclone, that Kerry called Medicane, and tropical cyclone, it's a sort of tropical transition. But the idea is to consider separately or as a two different aspects, or as two categories within the same name, these two cyclones showing different physical features. So conclusion about also the similarity between different objects in the different areas. Apparently, the conclusion for polar laws seems that for this paper by Emanuele Rotuno in 1989 seems to apply also to Mediterranean cyclones. That you have both baroclinic instability and their interaction, and one mechanism may dominate the other in particular circumstances. Just one slide for the comment to the poster that is outside. We try to classify, to distinguish these two categories also in a climatological sort of large-scale perspective, using the fact that the radius can be reduced in the most intense, in the major stage or not. And we found that really the two categories of cyclone identified in this way show different characteristics in terms in particular of K and of wind shear. And if you wanted to know more about this, have a look at the poster. It's interesting that the case developing in January a completely different characteristics. So very limited cape, and very intense low-level wind shear. So I hope that this definition that is we are working on for 3-4 years will come to some conclusion. But I hope that in the following discussion we can progress significantly. And last slide is about acknowledgement of different activities that allowed to do some progress and really created a network about Medicanes about the study of Medicanes. First, the post action led by Manos, that will be followed by the one led by Samira. The ISA contract, this new project that is led by Giulia Palagrossi, mainly related to remote sensing investigation, and finally to the activity that was developed in this interesting week. And for sure, we had already the possibility to discuss several aspects to clarify some of our ideas. So, thank you. If there are any questions.
Thank you very much, Marcello.
Oh.
Okay, thank you very much, Marcello. I think lots of material for the discussion after the break. Yes, so question, comment. We keep everything for after the break? No, there is no.
No, just a comment. The two differentiations of the that you do with the 2005 and 1996, also with the PV structure, you can also see, no, that the one remove PV at the levels, and the other one is not able to remove.
Yes,
So
this is another feature, yes.
the other one is more compatible with with one seclusion. So because one seclusion, the interaction with the upper PV anomalies is different also. So I think from that. Another thing is that the slide the light about the main hypothesis. Now I have to say that, well, that slide was in 2017, but now after the Kerry talk, I'm not sure that.
But anyway,
it's like that.
It's a good starting point, not to see that there are different evolution.
Yeah.
So this is, I think, what emerged already.
Yeah, so
Monday,
that's a good point to talk later, to discuss later about that.
Yeah, so perhaps on the same line, I think that it's very important for a community at a certain point to define something and to avoid to enter in this sort of spiral of like not defining things and go on for decades and decades, as it happens, for example, for the blocking, right? So could be a very nice output if like a joint effort to define with all these projects that at a certain point we come up with a definition that of course will have some limitations, right? But
just to have a common language.
A common language, yeah, a common language as it's done for yeah. So I don't know what you think about this, but that will be the topic of the next discussion. That sounds very.
Could you put on your previous slide that said work in progress on that definition?
Yes, but this is an old. It's not the most recent definition we have. This is just I think at the beginning of the work.
Yeah. So perhaps since I don't know if there is one offline. So yeah.
There's one question online saying, thank you for the interesting lecture. I was wondering whether the precipitation distribution across the life cycle was different between the two types of medicanes.
This is a good question. I think that there you can see some different evolution, in the sense that I would expect, I don't know if there are some particular studies dealing with this. I'm not aware. But in general, I would expect clearly that those subject to a tropical transition, or for example, we did several simulations with the Llanos, and it was impressive the amount of rainfall that you can extract, while generally for the other is much more limited and the evolution is faster. I don't know if you have some experience of some paper dealing with this aspect. I think that the paper by Xing has some climatological features about the mean structure, but not distinguishing between the two categories. I think this is not something that has been analyzed in particular.
Okay, so thanks, Marcello, for this prelude of what is coming at 11:30. And so now it's time for coffee or cheese.
Or both.
Or both. Also, I'm taking pictures of you and I'm sharing in the Slack so that. But I mean, you can also do this. So yeah, and there are the first articles that come up in the press for the press conference. There is one from Le Point, and if you are aware of press articles or interviews, or you're doing outreach activities around Tropicana, please let us know so that we can keep sharing them on LinkedIn, and then of course we can put as output of this nice program. Thanks. See you here. Yeah. Okay. Yeah. So, and do we have a Zoom? We can keep the Zoom link if, or the discussion will be just. Okay. So for those who are online, yeah, we will reconnect and see if there is, of course, someone who want to contribute from remote. And thanks for being so active also for remotely. Grazie Roberto.
Ma hai scaricato oggi poi quando fai lavorare tutto il tempo. Mi dispiace non poter essere qui la settimana prossima.
È per questo ti faccio lavorare oggi.
Sì, no.
Sì, perché la settimana poi parliamo di attribuzione, ma questa poi possiamo vedere anche quando vengo a Nucleo.
Purtroppo io quella settimana.
No.
Guarda, quella settimana
Devi fare un visiting, no, devi fare un visiting qua. Così scappi da te. No?
Guarda, spesso credo di conoscere alcuni di te, ma non credo di darti nessuna
Qual era il tuo sono grosse, c'era piccole varianti.
è rimasto un po' dire dubbio, non di lavoro. Quindi sono cambiato tutto. In realtà noi abbiamo quando di testi di abbiamo pubblicato. Ti credi in realtà? È sempre più importante per spiegare il presidente un piccolo
Sono orari, quindi è molto lavoro.
Comunque a me sembra che in molti casi la parlere anche mi pare che tutto sia che a volte noi vedo che c'è un semestre rimasto magari la definizione perché fare questo con la diciamo che la
Yeah, that's the idea. It's like getting the LAO pattern, yeah, 1 year of data. It's not much more difficult than the size LAO pattern. The idea is you need 32 years, but they didn't show us. So here the idea is we provide the more parameters, but definitely not at the end. The analysis will tell you that we are parameter is not how to work. So here, yeah, those patterns are here. Well, because normalize the normalize the anomaly, so we have to precipitation all the variables are in a dimension. That's the one. Then so they are. And also it's important to the more line on But the idea is that it's not the variable, the original variable is the original, but you also you can put everything what you want. So imagine that you put I don't know, a variable that's not related to cycle. So at the end, the PTA will tell you that that's important. Es buena charla, Jorge. Tienes una cantidad de trabajos para enseñar. Ya no doy para más ya porque